Okay, so the beginning part, we're just gonna do the little beginning part on 3-1 because then we've covered the words parallel and perpendicular and skew so that the second part of the lesson makes sense. So right now from lesson 3-1, parallel, perpendicular, skew, and parallel planes. Which word have you not heard of before? Probably skew. I think the others you have heard, but we need to get the details on what the definitions are for those others. All right, parallel lines, and there's parallel planes also. You might notice the word parallel up there twice. Okay, parallel lines, and here's the symbol for parallel. It has two up and down lines, no arrowheads on them. But parallel lines are coplanar. What's that mean? On the same plane. And a plane is? Left-hand one? I think he named FHD and EGC. And I think there's one more pair. Can you pick out the correct ones? What other pair appear to be parallel? Kelsey?
FGH and ABD.
She did name the front and the back. Why aren't we using all 4 points? 3 non-collinear points will determine a plane. So it's kind of like you're making a triangle out of those and then that whole plane that they contain. All right, so parallel planes, perpendicular, or parallel lines, perpendicular lines, skew lines, and also parallel planes. Okay. It says segments or rays can also be parallel, perpendicular, or skew if the lines that contain them are parallel, perpendicular. So if it's part of the parallel lines, then the rays are parallel. Because on this picture, we did not extend all the sides to be parallel or to be lines. All right, check of understanding. So now either on your paper or you can use iPad if you want to use it. Get you some of the details as far as how you should write it. You should have some segment symbols in there. You know, on the first one, looks like there's more than one pair of answers. I have segment, some of you were using the line symbol. Segment BF, how about is parallel to symbol? Segment EJ, BF and EJ. Okay, those had the 1 arrows. So as long as what you're naming are 2 of them with 1 arrow on them or with 2 arrows, don't name BC and ED. BC and ED that don't have any markings to indicate that they're parallel. Skew segments, again, could be more than one answer. I have segments BF and DE. BF and GH. Yeah, that would work. BF and, as long as you don't intersect BF, and then it's got to go a different direction. So BF and CD could work. You don't have to use BF. Any question? Want to check your answer on those? Very confident. Perpendicular segments, there's only one right answer because there's only one perpendicular marking in that diagram. So the only one we have is segment BF being perpendicular to FJ. And then the last one, plane, we don't have a symbol, but write out the word so we don't think you're just randomly listing points. So plane FJH, which was the bottom, I thought was parallel to plane BCD, which is the top. And you could name the front and the back or the left and the right. Any thumbs up or down on your results? Question on something, Grant? No? Okay, so we don't necessarily need to do a whole nother set? All right, that little bit we were going to do from chapter 1 or section 1. Then related to that, let's flip to section 3.5, and we're actually going to focus more time on 3.5. 3.5 focuses on slope. Review of algebra a bit, but then we're going to look at parallel lines and perpendicular lines. What relationship do their slopes have? So that's how we're tying it into the first section. So what is slope from algebra? slope means?
Rise over.
Rise over run. What is that? What's it tell you about a line? We've talked a lot about what's the slope of the line, what's the slope of the line. What are you really describing? Distance of it? Lines, now we know, go on forever. So distance, how long it is, no, your slope's not telling you how long it is. What's the slope really telling you? I know it says rise and run, and there's even a formula, but what is that? What's slope? Okay, all lines have a lot of points. I don't know that that tells me what slope is. What is slope? Why do I have a picture of a mountain?
How
far
Okay, the decline or the incline. So what does slope tell you? About a line. How far it goes up or down, the slant of it. Yes, it's the rise and the run, but maybe we'd say the comparison or the relationship of the rise and run, how steep it is. You know, is it just a little bit steep, or is it a lot steep? Is it going down, or is it going up as it goes to the right? So the slope tells you like the steepness, the slant of it, that kind of idea. We do use rise and run to determine it. So let's see what matches up with some notes. The slope of a line in a coordinate plane is a number that describes the steepness of a line. If you couldn't answer my question, write that down. The slope describes the steepness of a line. Maybe there's not a blank for it, but write it in there. Slope describes the steepness of a line. And we can graph it and count. You mentioned points. Yeah, we can use 2 points on a line to determine the slope. And there's a formula that we're going to be using a lot. Should be reviewed from algebra. So in the kind of notes area there, we have a rise, which is the difference in the y values. The y's is the rise, how far up and down. The run is the difference in the x values, how far left and right. So to do slope, if we refer to our 2 points as x1, y1 and x2, y2, this formula for slope should look familiar from Algebra 2. What students often get mixed up is, because the x's come first, we want to put that on the top. No, that's not rise. So it's y2 minus y1 on the top, x2 minus x1 on the bottom. And another thing that we goof up more in the distance formula than this, don't subtract the coordinates of 1 point, because that's an x and a y. It's not both x's. So make sure you're using the y's to subtract for the top, the x's for the bottom. Okay, an example. Let's make up a problem here. Okay, on this one, use the slope formula to determine the slope of the line. So we want the line AB. So let's write down what's point A. And what's point B. Probably should have just made that whole one big square instead of separating. A is the point, what, -2, 6?
7.
Is it 7? 7, yes. And B is the point 3, 7. Okay, so write down your 2 points. And now use that slope formula, it's in your notes there. Calculate the slope. Y part minus the other y part. In the same order, the x minus the x. If you switch the order, you're going to have your answers off by the positive or negative all the time. So you have to be consistent which x comes first, which y comes first, make sure you do that in both. So what's your numerator here?
0.
0. What's your denominator? 5. Did anyone get -5? Kind of depends which order you subtract, but it really wouldn't matter. What's 0 divided by 5? 0 or undefined? 0 divided by 5. Okay, let's write this down a little bit. I'm going to try and leave my bell ringer up there for next period. Okay, 0 divided by 5. If I do that long division, 0 divided by 5, what can I multiply 5 by to get 0? 0. 5 times 0 is 0. You can do that. So 0 divided by 5 is equal to 0. Now, if it were the other way around, 5 divided by 0, 5 divided by 0, what can I put up here that when I multiply by 0, I get 5? Can't do that one. So that's the one that you can't do. This, we use the term undefined, meaning there is no such number. Can't do that. If you need a reminder, write that down on your notes. Something like 0 divided by 5 is 0, but 5 divided by 0 is undefined. So what kind of a line was that? When you look on the graph, what would you describe AB as? It's going flat this way. Don't say it's straight. All lines are straight. What's the word for it going this direction? Horizontal. Horizontal. Okay, same picture. Let's do line AC. Find its slope. AC. A again is the point -2, 7. But now C is the point 4, 2. Calculate the slope. Done? Does it agree with the picture? Do you have a positive or a negative? Negative? Negative means as you look at the line, it goes down as it goes to the right. I always got mixed up, okay, if it goes down to the right, yeah, it goes up to the left, so it should be positive or negative. Well, keep in mind or think about reading a line just like you read a sentence from left to right. So as you go from left to right all the time, it's going down, so it should have a negative slope. So -5, 6, thumbs up or down? Morgan, did you get it right? All right, how about AD? We'll exhaust all the lines on this picture now. Line AD, calculate its slope. Makes sense. AD, it's going straight up and down. It's really steep. Come up with a slope. -6 over 0. What's -6 over 0 equal? Undefined. Your answer should be undefined on this one. Undefined, and notice on the graph that line is going straight up and down. Vertical lines always have undefined slope. And the last one we haven't done, well, I guess I didn't put it on there. Or maybe I put a reminder. Okay, CD is the last one. CD. What's its slope? So CD as you go to the right goes down. Looks like you should have a negative on the top. Plus negative 2. Over -6. Get yourself to that sentence. Negative divided by negative is not. Let's see if that makes sense. As you look on DC, it's going up, it goes to the right. It's not going up a lot. How much does it go up for how much it goes over? The slope was? Not 0.6.
1 negative 6.
Is it a negative slope or positive slope? DC, as it goes to the right, is going up a little bit. So it needs to have a positive slope. I think it should be positive 1/6. Now, then check and see. Did you get a negative on the top? You had 0 minus 7. Okay, I think you used your points wrong. -2. Oh, you're using. Are these the 2 points you used, or am I up here? Oh, I'm up here. Okay, 4, 2, and -2, 1. Okay, so 1 minus 2 is -1. On the bottom, -2 minus 4 was -6. So negative divided by negative should be positive. Better make a note of that. Negative divided by negative is positive. Okay, I think that we got through each of those. Let's summarize the signs. Now this is how you can kind of check to see if your signs are right. A positive slope is going to be a line that goes up to the right. You have to draw it exactly like you know. Just I put an XY axis, and then the line that goes up to the right is going to be a positive slope. A negative slope, as it goes to the right, it's going to go down. Might go down a little, might go down a lot, but it goes down. 0 slope, maybe you should write the fraction that's equal to that. A 0 slope is going to be a 0 on the top and a number on the bottom. 0 divided by something. And what word could you maybe put near this picture? What kind of a line is that one? Horizontal. Try and get all your reviewing things together. And then the undefined slope, it's a vertical line. Vertical line. What kind of a fraction would you get when you do the slope there? Look at the board if you need a reminder. What's an undefined end up like? Some number over 0. Yes, that's the type of slope you would get. So again, you can use those to kind of check yourself, see if you're getting your signs right. All right, now we're going to do some calculating. Use the slope formula, determine the slope. I guess this time I just didn't give you a picture. I don't think we counted on that last one, but let's just go from 2 points for an example. What's the slope, even if you can't look at it? Determine the slope. this any different than what we did before? Not really. We just don't have the graph to look at to double check. Are you ready for an answer? Okay, slope was 2. When we go to graph, we like to have a fraction, 2 over 1, but actually it does simplify to be just 2. Okay, and raise your hand if you got that one right. All right, I don't think they're coming up with the correct slope. -4 and -4. Check your slope on that second one. Let's see. Okay, so they're going to need to double check their slopes. Gee, I don't know why things are popping up weird here. Looks kind of crazy. Trying to figure out what's what. Okay, let me go back a little bit then. All right, I'll just leave it right there for right now. Maybe I can't write up there either. All right, second one. That was this row. What did you think they were? Perpendicular? Okay, looking at this picture. And did you measure it with your 90-degree angles? You measured 90? Okay, let's check and see. What were your slopes?
-3/7 and 2.
See if they ever pop up here. -3/7 and 2. Okay, now those should be neither. So try measuring your angle. Again, it's not quite 90. It's off by the 5, so it's like 85 degrees, 95. So they were thinking it was perpendicular, but according to those slopes, we'll get to the theorem here, the slopes did not indicate that they were perpendicular. Okay, let's see what I can do on number 3. What's your group think?
Excuse me, perpendicular.
They look perpendicular? Okay, what slopes? First slope. 1 and -1. Let me see if my screen ever pops them up. Perpendicular, 1 and -1. Yes. Okay, so they were correct. This row, parallel. They have real close together. Parallel, what slopes? 2, 4, and 5, 10. Can you reduce? Is it 2 or is it 1/2? Which was yours? The bigger numbers on top? Okay, Grant, you better check. Did you do the X's on top or the Y's on top of your slope formula? So it sounds like, are both of them 2? Okay, so on number 4, parallel, 2 and 2. Yes. No idea what's going on up there. Okay, 5th row. They look perpendicular, and you said you measured with the 90 degrees. Okay, slopes.
3 over 2 and 2 over 3.
So 3 over 2 and -2 over 3. Correct. Okay, so determine the relationship between the slope of parallel lines. There are a few rows. What that first row end up with when you double checked? Did you get your parallels to have the slopes that were right? Okay, so what relationship did both slopes have for parallel lines? That row had parallel and this row had parallel. Look at your slopes. What was special about them? They were the same. Okay, the theorem, parallel lines theorem, what does it say? Read through it for me there. Read through. Zach? Opposite reciprocals will always have a product that is -1. So if you recognize them as opposite reciprocals, you can pick out the perpendiculars quicker. So what is the opposite and reciprocal of 1/2? Raise your hands, please. Opposite reciprocal. Opposite sign and reciprocal. Grab your marker board. Put it on your marker board. Get an answer from everybody. What is the opposite and reciprocal? So what we're trying to do is work on this perpendicular line one. What slopes are going to indicate perpendiculars? Write it on your marker board and then I'm going to ask you to show me. The opposite reciprocal. Okay, show me please. reciprocal but not opposite sign. Which one do you want? Yes. I want the opposite reciprocal, both things at the same time. -2 reciprocals, those slopes will multiply to be -1. Okay, let's see what else I have. That's the opposite reciprocal part. You know, on your assignment, you're gonna be given 4 points and do similar to what we did, but make sure that the 4 points make 2 different lines and not just the same one. For instance, it says if the slopes are the same, making your results appear that they would be parallel, like if you don't graph it, you just calculate the slopes. If you get the slopes to be the same, it could be that they're parallel, or it could be that they all line up in one line. So if I would do the slope of my 2 lines according to the slopes, I would say my lines are going to be parallel. But you need to graph it to make sure that they would be 2 separate lines, because in that example, they're not 2 separate lines, so they're really not parallel. It's just all one line. So when you do some problems like this, we're going to determine first probably what the slope is, and then if necessary, if you think they're parallel, graph them to make sure they're not the same line. Make sure they are 2 separate ones. Okay, so for an example, you might write this 3 as a fraction. 3 over 1. And that simplifies 3. Okay, what do we think? What are the slopes? Vanessa, what'd you get for slopes?
3 and -3.
3 and -3. Are they the same? Is 3 the same as -3? Or -1/3, I mean? Did you say 1? Oh, you said -3. Okay, look at your fraction, yeah. The 1 would be on the top, the 3 on the bottom. Okay, so 3 and -1/3. Are those the same numbers? Is 3 the same as -1/3? No. So they're not parallel. Are they the opposite reciprocals? If you multiply them, will you get -1?
Yes.
Yeah, because you get -3 over +3, so yes, that would be -1. So the lines are perpendicular. All right, I'm going to click a few more examples where I have calculated the slope. Let's analyze it. And that's what they look like. Okay, on this one, I'm going to show you, so look at the screen and just analyze. There's the slope of the first one. There's the slope of the second one. Okay, on your marker board, tell me, are they parallel, perpendicular, or neither? Parallel, perpendicular, or neither? Are the slopes the same? Do the slopes multiply to be -1? Or are they the opposite reciprocals? And if it's no for both of those, then it's neither. All right, show me. Have time to get it done? Okay, should be neither on that one. Neither, because the slopes were completely different. They were not those opposite reciprocals either. So they intersect, but not at a right angle. Okay, here's the next one. There are the slopes. What are they? Those slopes, would they be parallel, perpendicular, or neither? Show me. Are you sure they're parallel? Or are they lined up so that they're all in the same line? Nobody really graphed it, did they? This would be one that you need to check on the graph. So let's see when I graph it, okay, they are two separate ones. So this could have been, if these points were actually over, we could have had all four in one line. So that's the type you'll need to graph. And how about that slope and that slope? Boy, why is that doing that? I'm being entertained by what it's doing. Okay, undefined and 0. Parallel, perpendicular, or neither? Use your theorems. Who knows? This answer should be, show me. Should be perpendicular. Because that top one is undefined, so it's a vertical line, the other is a horizontal line. They are perpendicular. What theorem says that? That perpendicular lines theorem says vertical and horizontal lines are perpendicular. Okay, that's the type of thing that you're going to be doing on the assignment. Let's get a little bit of homework time. I know I don't get you very often, but here's a little bit. Page 148 is going to be the beginning where we had